And welcome in this new episode of our Arabic NLP series. And we have reached 20 episodes. And today we are going to talk about Arabic tokenization. Okay. So whether you are a developer or a researcher or you just like curious about how AI like understand languages like Arabic. So this video will be helpful for you. First of all, before I dive into the details, I would like to give the credit to this amazing Medium blog by Abdelmajid Rumi, who like explained some of about the tokenization process in Arabic for GPT models. Okay, and what you are going to see actually it is from that blog with more details about the tokenization process, especially when it comes to byte pair encoding, and we are going to understand this. So today we are going to explore why tokenization is essential for LLMs, and then the impact of tokenization when it comes to model efficiency. We will see some code example and how Arabic differs than English and other languages, okay? And we are going to implement and see how to do or to build an Arabic tokenizer for language models, okay? So here we go. So imagine like you are like teaching a computer how to understand the language. So the first step is to break down into smaller units, and these actually we call it tokens. Okay. Uh, so the idea is how you can break it, and the way that you break it into these smaller units is actually matters a lot. So, like others break text into words or subwords, and initially it was about like on like a character level, and then we have seen what's called like subword tokenization or subword level tokenization. So advanced models like merge common patterns to actually optimize the token usage. For Arabic especially, and I want to make this clear, there is like a tricky do you it's like right to left writing system, and also the complex morphology and the dialects. Okay, so let's see how this affects LLM performance. So before we talk more in details about the tokenization, of course, we need to know why tokenization matters for LLM. And first of all, it is really about text generation and understanding. So, how will the model will predict and structure the sentences? And other, we have like other reasons when it comes to the error effect in calculations, and then AI struggles like with programming languages because there is like some tokenization mistakes, and of course more tokens we have, it is like we need higher computational cost. So ever like wondered why AI sometimes struggles with math, or it like generates weird text, or like get confused when it comes to to non English languages? And actually, the reason is because of tokenization. So, like, if we tokenize a sentence like in Arabic, مرحبا بالعالم, which is hello world, okay, at the character level, we will get something like this. So each Arabic letter gets like a unique token, and of course, it will increase the sequence length, okay? Now, with advanced like GPT-4 like models, like the tokenization process is different, and it is starting like recognizing like common words as single tokens. So instead of presenting this in a link with a linked in sequence, we end up with this, which is actually reduce the token count. Okay, and this is of course will improve the efficiency. So let's explore how this works. Okay. Now, uh, like each tokenization is straightforward, like right? because we simply split into small units and the grammar or the words are clear. But in Arabic, like we have a whole different story. So as I mentioned, if we take like if we let's take example in Arabic like kataba, which is mean write, okay, or wrote. Uh, so it has many forms. When I say katib, which is means writer, and when we say like library, which is means the maktaba, which is the place, and when I say written, so it is already like someone has written this words, okay? So if the tokenizer now is not trained like very well, it might treat like maktub, which is written, as completely unrelated to kataba, which is the root-based morphology of that words. Okay. Also, we have some issues like Arabic doesn't always use spaces like English. So if you notice this وبالرغم, so it's like although, so a simple tokenizer might spell this very, very incorrectly, and like it's like it is like misinterpreting the words like wow, which means and make it like make it as part of the next word. Okay, so without a smart tokenizer, Arabic becomes like a nightmare for AI actually. So yeah, so to make AI handle multiple languages, and of course, let's start with the simple idea, which is Unicode, right? UTF-8, and I know like much of you like know this, and when you load like JSON file, like contains other than English, you are using this Unicode method, right? So it actually allows you to represent any character from any languages. Now, when it comes to Arabic, here is the challenge because Arabic characters actually requires 2 bytes to store. Okay, like English needs 1 byte, emojis need 4 bytes, uh, which is of course increasing the sequence length. So when we encode marhaba, which is hello in Arabic, it gives the following Unicode. Okay. So actually, any characters take 2 bytes each. So it's like doubling the token count compared to English. Uh, and of course, as I mentioned, like images like words because it's 4 bytes. So this is like balanced token counts and making the LLM less efficient. So that's why we have like another techniques that's called byte pair encoding. PBE, which is actually uh, it is like a game changer. So now most of the LLMs that we see are built when they build the tokenizer, they use this algorithm, and it's like instead of treating each characters like in a separate way, no, we merge common patterns. Okay, and this is the idea behind it. So the process actually is very, very straightforward because we identify most frequent character pairs, we merge them into new tokens, and we repeat until reaching the vocabulary limits, right? So here are simple illustration in English about how byte pair encoding work. So if I have like a small corpus here, like low, lowest, lower, right? Now, the first step is to have like initial characters of these. So I am going to split the whole corpus into characters, okay? And then I will start to see pairs of letters to merge and with the highest, of course, frequency. So starting with LO, which is three times repeated or seen in my corpus. So I am going to assign, sorry, going to assign three. And I will do that for the whole pairs that I have. Now I will take like the first one with the highest frequency merge, and I am going to update my tokens so I can merge it now. So instead of saying LO, it is a separate character. No, I have now an a merged token, which is LO together. and I am going to repeat the process with my corpus. So LO with W, I can see it 3 times here, so I am going to assign 3. WE, I can see it here and here, so I am going to give it 2, and I will keep doing this for the whole tokens, right? And I will repeat the process and recalculate the pair frequencies, and I do merging. So if you notice here, when I update the tokens, I start seeing some subword level, right, of that tokenization. So after we merge, we end up with a vocabulary, okay, and a merge. So this is actually at each iteration I do merging. So you can see now I end up with these 5 merges, right? And of course, you can see the vocab that I made or I have. So when it comes to a new sentence, like in English, like this one, now using my vocabulary and merge, I can see that, for example, when it comes to lowered or the lowest or whatever, like we have here, so simply I can see, okay, low, which is I have done, okay, a merge, and I have like ER, so I will consider that as a token, and I will complete this process until I have the final tokenized sentence. So this is pretty much how this is work, okay? Now, the GPT tokenizer actually built on PBE, but of course, like it improves the efficiency and it likes avoid the unnecessary token splits, okay? Especially for Arabic, and we are going to see that like in code, okay? So here we go. Let me just go and clean this so you can I can explain this for you. So now we first going to start with byte pair encoding code illustration, and this is directly from the blog. So you can go there and see more details about it. But like imagine we have the Pro Arabic greeting like Assalamu alaikum wa rahmatullahi wa barakatuh. So this is like there is like occurring character each as meme, right? This letter you can see it here and of course here. So we will using like byte pair encoding to pair those occurring characters together. We first can convert this like into a list of numbers, so you can see the UTF-8 or the Unicode, I mean, so, and you can now see the increasing in length, right? So next we can use or we can do like some function to find like the pairs of numbers, so which represent the little pairs, okay, and that like appear next to each other, okay, as you can see here. So this is process is the actually the start of the pair of the byte pair encoding, as I explained, where we aim to make like the next or the text easier for computers to understand by like simplifying repeating patterns, right? So now you can see for these counts of pairs, and actually when it comes to like if we want to see this one, which is 217, 132, 132, which is like represent the letter lam, okay, which is that one, L, lam, okay, and we can see it like many here. So actually, if you go and count here, you are going to see it like 5 times. So if we directly uses this to find the max stats, we are going to see that letter, okay. So now we need to do this merging. So we will implement like merge function as a key part of implementing part or I mean PBE. So this is a method for text compression and tokenization, and especially useful like in NLP, as I said. So here we are going to check, and if it is like the appears the max, I am going and do some merging of this and updating the index, okay. So if I took this like example now, uh, what So now this code actually takes like a list, right? And looks for two specific numbers that are next to each other, okay, such as this and others. And when it finds them, it go and replace them with a new number, okay? So of course, this new number that you have already chosen, then it choose like a new list after these changes, okay? So let's run this code, which like we have like a vocab size, and it will do the merging with getting the stats and everything. Okay, so now what I mean by replacing my corpus that I started with the grading, I mean now I can see for the most occurring one, I merged with the new token, I mean with this ID. And I did this like for the whole corpus, right? And of course, like I can see the token length, and when like I do like the compression ratio, I can see now the IDs link that I got, right? And actually, the purpose of this code is to take a complex piece of text, then identify common patterns like frequent pairs of characters, and then simplify it by merging these patterns into single symbols. So this makes the text easier to analyze or process because there are like fewer and also more meaningful pieces to look at. So it is better than the one that we start with, right? For individual characters, I mean. So yeah. So now I can like do and I can apply the decoding and encoding, which is actually this is about tokenization. So I encode the text into these IDs and I can decode it to get the original meaning. Okay, so but here are like some important things that I need to mention. So now we can apply the decoding first, which is we can like highlight some points. So not all byte sequences from like form valid UTF text, and we know this. So if we try to decode the byte like 100 to 80, like a UTF-8 throws an error because doesn't like conform to UTF-8's encoding rules. So this part of the talk aim to educate of the specifics of UTF-8 encoding and why certain byte sequences might cause some problems. So we have done like this for encoding, so we can do errors equal replace just to ensure that any invalid byte sequences can be replaced with special characters. Okay, so that's why I just the blog and here in the code into introducing the decoding first. So the solution presented in involving like using errors equal replace is to ensure that any invalid, as I said, like replaced. Okay. Now, when we decode bytes like the one like yeah, this is for encoding. So maybe I can run this quickly and show you the example here. Then we can talk. So it's be true, and I am going to explain why this is occurred, right? So uh, for encoding, okay, uh, so in which we encode text into tokens, right? Now, which is the process of converting the string that we have into a sequence of integers, and based on a predefined set of rules or a vocabulary that I have, as I showed you in the slides, like we follow that rules of vocab to end up with the specific tokens. So we do that because encoding text into tokens, it is like a very foundational for transforming a natural language into a structured and also numerical format that the machine learning or the LM can understand. Okay, uh, so in this code, actually, we apply iterative uh, merging function. Okay, so iterative merging a function which is like enters a loop where it is like repeatedly looks for pairs and then combine. So this is merging process simulates how more complex tokens like words or even subwords like can form from simpler ones, better than of course like the character based or the bytes, let's say. So this code actually just to validate, okay, if we can do the encoding decoding process. So if we verify the original text can be recovered without a loss or alteration after being transformed into a sequence of tokens and then back into text. So if it gives true, that means that the encoding and decoding process for Arabic text like works correctly, as you can see. So here's like a more fundamentals, let's say, about pair encoding, and of course you can go directly and yeah, so and apply like GPT tokenizer for Arabic, right? And we can see this actually regex example using find all. This is popular when you import like regex. So using find all function of the re module will search for and return all substrings that match the pattern defined here, right? So this is like segments the input in string into a list of tokens according to the specified character. Okay. Now, so now, as you know, when we deal with regex, this pattern like specifically designed into identifying or separating different types of tokens with a text for processing. Okay, but when it comes to tokenization, and we want to not doing regex, but instead training a very large corpus in order to learn that patterns and do the merging for the high and end up with like subwords that can be able to tokenize into a subword level, I mean. So if you go and pip install TikToken, which is the tokenizer specified for GPT models, and you can call these models that deals with GPT-2, the fundamental one, and GPT-4, we can directly notice the difference. Okay, and yeah, of course, and this is the remaining code to get the vocab and encoder if you are interested to see, because as I told you in slides, you end up with two files, like the merge and the encoders. But actually, you can also visit this platform of OpenAI and actually see how the legacy model start with not identifying well for Arabic, and when it comes to 3.5, it like doing this and somehow character based and like ending up with more tokens. But when it comes to GPT-4 or GPT-4 mini, now we can see how we reduce the tokens into a really subword. And this is, many people have noticed that how GPT-4o and GPT-4o mini is better in terms of cost when it comes to Arabic, because you know, the cost is on bare tokens. So if you deal with these legacy models, the token now, this one or this one has a price. But when it comes to GPT-4, the whole world now is a token, which is of course will reduce the cost and will make it more efficient actually. So yeah, this is conclude our conclusion our discussion about Arabic tokenization. And tokenization is not just like about spelling text, like it shapes how LLM like understand languages. So yeah, we have seen like how Arabic challenges like in AI and LLM, and how like BBE and GPT tokenization improves the efficiency. Now we can go and understand more about how open sources like Llama, Mistral, Gamma do the tokenization for Arabic, and we can introduce something new came in the latest Arabic LLM called Fanar. It's actually a morphology BBE or a morphology-based BBE tokenization, and we need to study this, or we need to learn this and see how they improve the efficiency actually in that model. So this is might be like next episodes when I discuss more advanced techniques for Arabic tokenization. But for now, that's all, and I hope this is like helpful for you. So thank you.